Hello my dear children of class 12 science. Now we start the last chapter as per reduced syllabus. Okay, in wave optics, and this is a short chapter, okay, which is called diffraction of light, or we simply call as diffraction. Okay, now this is one of the important topic or chapter under wave optics, like we did on the chapter called interference of light, which is important. Okay, and this is important also for your college level also. So diffraction light concept is also important for college level also. Okay, now wave optics actually deals basically with the nature of light. It's explain the nature of light, saying that light travels in the form of wave. Okay, so other than reflection and refraction light, there are other properties of light or other phenomena of light that can be understood with the help of this wave optics. And one of the property or phenomenon that you have learned is called interference of light. So in a similar manner, we have another property that has explained by the wave optics using Huygens principle. This is very important. Using what principle? Huygens principle is called diffraction of light, or we simply call as diffraction. Children, you know that in case of ray optics, you learn that light travels in a what line? Straight line. Light travels in a what line? Straight line. So we have learned that light travels in a what line? Straight line. Now light travels in a straight line means there is no bending of the light takes place. Light passes straight. But this phenomenon is basically true or applicable if an obstacles, okay, if the obstacles or the aperture whose size is large compared to the wavelength of light, whose size is large compared to the wavelength of light, so that there is no bending of the light takes place at the corner or the edges of an obstacles. So light almost travel straight. Light almost travel what? Straight. So under this case, if an obstacles, okay, or aperture means a very small hole, okay, be placed between the source of light and the screen. Between the what? Source of light. Suppose you have a source of light and there is a screen. And between that, if you put some obstacles, obstacles, okay, obstacles, or we also call it aperture, okay, whose size is large compared to the wavelength of light. Then what happened? We can see on the screen illuminated light. Okay, we see on the screen the illuminated light, or we can see a shadow forming on the screen, and this shadow which form on the screen shows that the light travel almost approximately in a what line? Straight line. Light travels almost in a what line? Straight line. Just showing again once the diagram. Suppose you have a small slit. And this is the width of the slit. And if you pass the light pass through this slit, okay, in the form of wavefront. So I consider this is a wavefront, and I'm taking what wavefront? Plane wavefront. This is what wavefront? Plane wavefront. In the form of what wavefront? Plane wavefront, according to Huygens principle. Then what we basically observe that there is almost very negligible bending takes place at the corner or the edges of an obstacles. That means light almost goes straight this way, plane wavefront. So the illuminated light from this slit is almost plane. Okay, almost what? Plane. And this wavefront which passes almost straight, okay, without much bending at the corner of an obstacles, so that the light almost travel in a what line? Straight line. Light almost travel in a what line? Straight line. Means if I make the light to pass on this slit, in this slit, suppose if I consider this slit is AB, if I give the name of the slit as say AB, then there is almost very small bending takes place at the corner of an obstacles, so that when it emerges out from this AB, the slit AB, almost the emerging ray or wavefront almost become the plane wavefront. So that the ray which come out from this slit is almost a what? Approximately what? Straight line. Approximately a what line? Straight line. Now this is basically true when the size, or I can use the word width. We call the width, the size of the width of what? Obstacles and that obstacle is this one, AB, is large compared to what? Compared to the wavelength of light. Large compared to what? Wavelength of what? Light. See, light produced from any source has a wavelength. Okay, but only thing that we need to keep in mind out here is, children, the light from a source can be a monochromatic light, it can be a white light. But we are sending a what light? Monochromatic light. A light of particular color of a particular wavelength of light. So basically light has less wavelength. But if the size will be large compared to the wavelength of light, say if I consider, if AB is large compared to lambda, and lambda is the wavelength of light, then there is no bending, almost negligible bending takes place at the corner of an obstacle. We show that the light emerges out from this slit, almost travel approximately what line? Straight line. So that the emerging wavefront almost become a what wavefront? Plane wavefront. Okay, but this is the phenomenon which explains that the light travels almost approximately what line? Straight line. But we are actually concerned out here with the diffraction of light. So in order to define and in order to understand what is diffraction of light, so we can change the size of the slit or size of an obstacle or aperture. So if I make the size of the aperture or obstacles to be very, very small, whose size is comparable to the wavelength of light, compatible wavelength of what? Light. So in that case, basically what we will observe, there is more bending of the light takes place at the corner of an obstacles. More bending of light takes place at the corner of what? Obstacles. So due to more bending of the light takes place at the corner of obstacles, okay, this phenomenon of bending of light around the corner of an obstacles or aperture is basically called as diffraction of light. Basically called as what? Diffraction of what? Light. So in a simple way, to define diffraction of light, it is the phenomenon of bending of light around the corner of a very small obstacles aperture, okay, so that this bending makes the spreading of light into a region to form some changes or some modification in the distribution of light energy, which is observed on the screen, and this phenomenon is basically called as diffraction of light. So that's why, children, in order to define diffraction of light, the size of an obstacles or aperture should be comparable to the wavelength of light. So it doesn't mean that when you pass light from the source to a small hole, it will observe diffraction like that. Okay, so the condition is there for diffraction of light. So children, as for the explanation which I made just now for the diffraction of light, and that can be understood with the help of this diagram also. So this is a diagram that actually defines diffraction of light. The same slit, but if I make the slit very, very small in size, so very, very small in size, so that the width of the slit or the size of the slit, that is AB, is comparable to the wavelength of light. So lambda means the wavelength of light, and this sign is nearly equals to, means when the wavelength of the light is comparable to the size of the slit, the light which is incident on this slit in the form of wavefront, and this wavefront is called plane wavefront. Okay, so what happened? There will be more bending of the light takes place. There is more bending of the light takes place at the corner of an obstacles. There is more bending of light takes place at the corner of a what? Obstacles. But children, remember this happens only when the size of the slit or obstacles, or we can use the word aperture, AB, which is comparable to the wavelength of what? Light. So that there is a spreading of light takes place. Okay, there is a spreading of light takes place by the certain amount. Due to the bending, as I said, due to the bending of the light takes place at the corner or the edges of an obstacles, and it emerges out to form some geometrical shadow on the screen. But this geometrical shadow which is formed on the screen is actually due to the modification or due to the modification in the distribution of light energy, just like your what? Interference of light. And this phenomenon of bending of light around the corner of a small aperture or obstacles is basically defined as diffraction of light, or we simply call as diffraction. So this diagram basically makes you what is diffraction of light. So under this case, you can see the light which is incident on the slit is in plane wavefront, but when the light spread out is not in the form of plane wavefront. There will be a spherical wavefront. This wavefront will be a what wavefront? Spherical what? Wavefront. So why it is happening? Because of the bending of light more about the corner of an obstacles. But the question arises out here is, how will be how the modification light or distribution light energy takes place when some pattern is formed on the screen. Now this is actually due to the concept of Huygens principle. So in case of diffraction light also we have to apply Huygens principle. So children, if you look at this diagram again, in this particular diagram you can see the plane wavefront is advancing towards a very small what? Aperture. Okay, very small what? Aperture. So once it advancing towards very small aperture, then what happened? Most of the part of the wavefront, most of the part of this wavefront, okay, is reflected back from this aperture. Then only a very small portion of this plane wavefront, okay, is passed through this aperture or slit, that is called AB. So under this case we can apply Huygens principle. We can apply what principle? Huygens principle. So as for the Huygens principle, the aperture, this particular aperture AB, okay, act like a new wave source. It act like a what? New wave source from which a fresh wave generate. And these waves which generate by this source are called what wavelet? Secondary wavelet. They are called what? Secondary wavelet. And this secondary wavelet will advance in all the direction with the speed of the original wave which reaches to this slit AB. So as a result, if you see, okay, there is a what? Spherical wavefront emerges out from the aperture and advances with the same speed as the speed of plane wavefront approaching towards the what? Aperture. And children, you know very well that in a homogeneous isotropic medium, the wavefront is always perpendicular to the direction of propagation of wave. So if this is a spherical wavefront, then these are the rays. These are the what? Rays. So as a result, if you look at this diagram, okay, the wave which emerges out from this small aperture will not move only in a straight line, but it also bend. That's why you can see there is a bending of the light takes place at the corner of an obstacles. And this is actually called as diffraction of wave. This is also called diffraction of what? Wave. So under this case, when you put some screen somewhere out there, suppose you put some screen out there, okay. Now when you put some screen, okay, behind the aperture, then the intensity of light emerging from this small aperture is distributed on the screen in a certain manner, depending upon the nature of the what? Aperture. Depending upon nature of the aperture means especially with the size of an aperture. So the intensity distribution which is observed on the screen, okay, is actually called as diffraction pattern. It's called what? Diffraction pattern of the what? Aperture. And the diagram of diffraction pattern which is formed on the screen I'll show you in the next YouTube video. But the main question arises out here is why there is some diffraction pattern, just like interference pattern formed on the screen. It's because of the secondary wavelet that is produced from different part of this slit that will spread out in all the direction, and this secondary wavelet will superimpose. This secondary wavelet will superpose in such a manner so that some modification of energy distribution, light energy takes place in this pattern, forming diffraction pattern on the screen. And due to this superposition of secondary wavelet produced from different part of this same wavefront actually leads to the formation of diffraction pattern on the screen. And this phenomenon is basically called as diffraction of light. So children, remember this, diffraction is simply nothing but the bending of light around the corner of an obstacle of aperture when the light of wavelength incident on the aperture is comparable to the wavelength of light. That's why diffraction phenomenon cannot observe under all the conditions. So there are certain conditions for diffraction light, and that condition also I will discuss in the next YouTube video with the help of diffraction pattern formed on the screen.